Let's talk about common logarithms. If you have log of x, that's equivalent to log base 10 of x. So this is one of the very few times that if something's not written, it's not going to be a 1. So if you have a base, if you don't have a base written, your base is going to be base 10 if it says log, if it says log, okay? This is called the common log. So if no base is written, what is the base? 10. So look at 7. It says find log of 17. Well, what's my base? So I could rewrite this as log base 10 of 17. And then we know that we're going to set that equal to y, aren't we? So if I try to set this up, though, in exponential form, what would my base be? And what is my x? And what is my y? So b to the y equals x. Can I solve that way? I can't. I can't take 10 down to a base of 7, and 10 and 7 both won't go down to the same base. So we're stuck. Oh, 17. Sorry, thank you. All right, still the same thing though, okay? So 10 and 7, 17 is a bigger base. It won't go down to a base of 10. And 10 and 17 both won't go down to the same base. So that means we can't work this out by hand. We already looked at it in log form. We couldn't work it out in log form. So I'm going to let you use your calculator on this one. So make sure you have your calculator out. And if you look at it, you'll see down on the bottom bottom left, where the on button is, right above it, you should have a log button and you should have an LN button. What does LN stand for? Do you remember? It's the natural log. That's what we're going to talk about next, okay? So, but look on your calculator. Do you see your log button? Our calculators are in base 10, okay? Because our entire number system that we use is base 10. That's why when we're talking about like decimals, we have a tenths place, a hundredths place, a thousandths place. We're talking whole numbers. We have ones, tens, hundreds, thousands, 10,000s. We don't have like a 50th place, do we? Or a second place. So our whole number system is based on base 10. So our calculator is going to use base 10. So where you see that it just says log, that's our log base 10. So go ahead and type in log of 17 and hit enter. And what does it tell you? It's approximately 1.23. Good. Now, could I have used this on the stuff in example 6? I could have.
So that's y equals 1.23.
Yes, our y is equal to 1.23. Alright, so a lot of times the logarithms we can work out by hand, but sometimes we have to use a calculator just because the numbers don't work aren't very nice to us. But when we move on here to natural logarithms, it says the natural log of x, which is ln of x, is equivalent to log base e of x. Well, what is e? Yeah, that 2.7 number. It's that irrational number, right? That represents it. All right, so when we're having these, unless it's equal to e to the something or whatever, then we're going to have to use our calculator. So I have to give in on it. So look at 8. It says find the natural log of 17. So do you see your natural log button on your calculator? So what is the natural log of 17 approximately? And what about 9? 9 says find the natural log of e to the 183. Yeah, it's 183. We could have worked that one out by hand as well. But yeah, because this is, I'll show you, because this is the natural log, which is log base e, right? So let me rewrite this. So this here is the same as saying log base e of e to the 183. And so you would know that your base is e, your x is e to the 183, and you're solving it, so y is just going to be y. And so when you set it up, you'd have b to the y equals your x. And then just like what we had before, our bases would have disappeared, and so y would equal 183. Yes.